And welcome back, and happy Christmas if you're watching this in December 2019. Now, last week we had a look at an on-off switch. It wasn't a million miles away from what you're seeing down here, that powered an Arduino, this one here, on and off with a simple push button. You can just about make out the push button at the back there. But what we didn't manage to do was emulate the circuit from the LTC2954 chip that I showed. Well, I didn't show it because I didn't have one, and the reason I didn't have one because it was too expensive, I said. And I said maybe we can emulate the full features of that 2954 in a future video. Guess what? I found a chip that will do it for us at a third of the price. In fact, it's all wired up and ready to go. So I think what we're going to have first is a demo, then we'll talk about all the features about it and this circuit here, which obviously you can't make out head nor tails of. But I've got a circuit diagram, hand drawn, crafted in fact. So we'll do that first. And of course, as last week, I had another whole ribbing about the glasses and headsets and things. So no more glasses this week. No funny glasses. In fact, I still can't see out of this eye. But I'm not going to put any glasses on to stop the glare because I just get too much ribbing. Okay, so that's the promise. No more glasses. So without further ado, let's have a quick demo of this device. So remember, this is an on-off push button, a single push button. Now I've got one wedged in the breadboard there. In real life, of course, you'd have a much better push button. If you were building this into a project, your front panel might well have something like this, you know, nice shiny push button, momentary on off though, so you push and it makes the connection and then you let go and it releases it, and that's all you need. Yes, if you wanted to, you could have one with an LED inside or next to it or whatever, makes no odds, but just for the demo purposes we've got one jammed on the breadboard there. So what we're going to do is fire up the circuit. It will power up this Arduino, and although you can see a cable attached to this Arduino, there's no power coming through here. As you can see, it's dead at the moment. That cable is only for the data because I've got the other end of this plugged into my USB port that allows me to switch off the power. Very useful, in fact. I'll show you a little picture of that later on if I remember. It's very good. Okay, so what's going to happen then? We're going to press the button. This is going to fire up and latch, which will then power this, so it doesn't matter how long this takes to boot up. If you remember that problem last week with all the bootloader delay, it was quite an issue, but now we don't have that delay anymore. Well, we have the delay on the Arduino, but we don't care because this circuit powers up immediately and latches on, and that's fine. And then we can power it off again by another switch. I'd like to give a big shout out to PCBWay.com. PCB prototype the easy way. Ordering from their website is easy. Enter your dimensions of the PCB into the little box, choose how many PCBs you want, and then press the quote now. You can then modify all the parameters the way you want your PCB to be made. There are quite a few options. And there are quite a few shipping options too. Choose the one best suited for you. Look at the range of boards they can produce here, and I know from personal experience their boards are really second to none. New users get $5 off their first order. So why not try them out now? Right, the two monitors that you can see, the serial monitors, the one on the left, so this one that I'm wiggling the mouse about on at the moment, that's the new stuff on this breadboard, and the one on the right is the Arduino just telling them what it's doing. Because if you remember from that LTC2954, it was clever enough to say, oh, I've had a request to shut down, tell the microcontroller that I'm connected to that I want to shut down please, and then wait for a response from that microcontroller to say, okay, we're good to shut down. Okay, so you'll see that here. Unfortunately, because I've got to power it up first, we won't get the second serial monitor up until it's powered. So let's power up. Right, so the first one springs into action and it is instant. That the second I press that button, it's on. Right, so it says I'm up and I'm ready to accept responses to shut it down as well. Let's connect it to this other one and see what that says. Right, that's the Arduino just been reset there saying, right, I'm ready. I'm waiting for something to happen. So if I press the button to shut it down again, so this one's saying, yeah, I've set it. That said, yeah, look, I've received something. It says go. And over here, kill, bang. Now that was all a bit quick, so we'll step through that in just a little while. Trying to look at two monitors and follow what's going on two serial monitors for me is difficult enough, and I'm well aware of what's going on. So we'll step through that a little bit. Yeah, I know, it's Christmas, all right, and it shields my eye. That's why I'm holding it there. Let's say I did promise no glasses, though, so there we are. Man of my word. Right, let's just go through these statements then on screen, and we'll see exactly what they're doing. So what's happening on this board, the one that does all the business now, nice and cheaply, it starts up, powers on, it says, right, I'm not accepting shutdown request just yet. That's just me putting something in there, so you don't accidentally press it twice and it immediately shuts down. So it leaves about 5 seconds before it says, okay, I can shut down now. I've left a few debugging messages in as well, just to prove it was all working. This was me pressing the push button to say, oh, look, the ISR's jumped in, and yes, it was an okay push. I don't mind that. The ISR, that's the interrupt service request of that push button, will only accept a falling request. And thanks to the viewer last week who said, I notice you're using low in some of your interrupts. You should really be using falling. And indeed, I do most of the time. But when I did the rotary encoder videos, I probably did 2, was it 3? 2 at least. Falling didn't really work too well, so I kept it as low, and it's sort of been a habit I've got into. But falling is the one you want. Why? If you keep it as an interrupt on a low and you press the button and you hold it in, then the interrupt's going to fire again and again and again and again while it is low. If you say I only want to fire it as it's falling, that is moving from a high level to a low level, it's only going to fire once, even if you keep your finger on the button. Okay, so that's definitely what you want. You don't want thousands of interrupt requests being serviced just because you're holding the finger on the button. And no matter how quickly you can do it, you know, just a jab of that button to a computer, that's an eternity, isn't it? Okay, now the next thing is, says, right, I've received the shutdown request. That is, you pushing that button has told me you'd like to shut down. So what I'm going to do now is send a shutdown request to the connected microcontroller, basically this part of the circuit, the Arduino. So the Arduino gets a request saying, oi, I'd like to shut down, please. Go and do some stuff that you need to do before you get the power removed. Okay, so over onto the second window now, it says, once the setup's been done, it says, oh, I've had something come in on a pin. We're using pin 2 here, also an interrupt. Now there were some comments last week about, do we really need it on an interrupt, or can't we just poll? Well, yeah, I suppose you can get away with it, but if you're polling, you know, in a big loop, who knows what you could be doing in that loop? I mean, I'll assume you're not doing any delays, because that would immediately kill it. You should not use delays in the loop. But any one of the things you might be calling could be doing a delay, and then you'll miss that pulse, won't you? I'm sending the pulse from the breadboard circuit to the Arduino, and I've reduced it down to 10 milliseconds. I'm bringing that interrupt low for 10 milliseconds. Now, of course, you could increase that. You could say, I'll have 100 millisecond low signals in order for that loop to find it. But I don't know, it just seems the wrong way to go for me. You got an infrequent pulse coming along on one of the pins, and I think an interrupt's the way to go. I'll leave it up to you though to make your minds up on that one. So the interrupt routine here has jumped into life and go, hey, I've just had a low on that pin. I'll set a flag and then exit, because that's what interrupt should do. Quick in and out. That was me snapping my fingers. Quick in and out. And then it says, okay, I'm doing some housekeeping requests here. In other words, you know, that SD card finalization, sending out an email, whatever. And then it sends the reply back, which hasn't actually come out on here because I suspect it all happened a bit quick. But what the first monitor is saying is, I've had the kill command come back. So the Arduino said, go for it. That's me putting my thumb up. So, and therefore, this circuit can now shut the power off. Simplicity itself, isn't it? But the ATTiny85 says, if your Arduino, or whatever it is you've connected to that power supply, does not respond, it's hung in some way, and never sends the response back, how are you going to shut it all off? Well, all right, you can kill it off at the main switch, can't you? But this now will also kill the power if this doesn't respond. Now we can emulate that by disconnecting the pin here to that interrupt. So we take that off. So it will neither receive the instruction to shut down, nor will it send anything back, because I'm using that pin for a dual purpose. So let's fire it up again. This time you'll only see stuff on this window, because that's the only one that's going to be responding. So let me start it up again. Right, so off it goes. Start it up. It says I've had the button press. Now you can shut me down if you want. The Arduino is still beeping, it's still running, but we're going to pretend it's actually hanging. All right. So when I press this button to shut down, it says, right, I've had the request from that button. I've sent the message to the Arduino or whatever it is you're hanging off the end, and I'm waiting. I'm waiting for that kill command to come back to say all good. And it won't, because we're pretending this Arduino is hung now. So what we now do is press this button for 5 seconds, and if you watch the flashing green LED, which tells us we're in shutdown mode, that is, you've pressed the button to start the shutdown, but nothing's happening yet. If I press and hold, watch the debug window here, you'll see that there'll be another message after 5 seconds. There we are. It's had the kill command and it's dead. So that now emulates that LTC2954 exactly. The difference being that you could have a different capacitor on the 2954 and increase that delay from pressing and holding that button from, I think the example they gave was a 1 microfarad capacitor, and it was something like 6.4 seconds. This one can do it from 100 milliseconds up to, you know, as long as you want. The bit that's in purple on the left, so basically these two MOSFET transistors should be pretty common to you by now. So we have a P channel at the top that actually interrupts the power supply. That's the real switch. And the one underneath it is an N channel. This time we're using a 2N7000 to control the gate going down to ground. So that's what switches that on, or keeps it switched on. And the 100K over here is simply to make sure that this stays off under normal circumstances when we haven't done anything. So this chip in the middle, oh, I haven't labelled it, hang on a minute, let me get my nice new pen. 85, there we are, which of course you knew, ATTiny85. What else would you use in a situation like this? It's got well, 2 pins for power and supply, power and ground, and then 6 other pins which we can use, one of which is the reset, so you probably don't want to touch that under normal use, but you could always use my fuse resetter if you wanted to use that as a proper GPIO pin. Here we don't need it. So what we're doing here then is saying, right, we fire up the Tiny85, when this switch closes here, let's get my mouse in the right place, so when this switch closes, it brings the gate here via this diode and this resistor to ground, and that is enough to turn this on. Only via this route though. This is doing nothing at that time. So this switch is on, which then of course powers up the ATTiny85. The ATTiny85 does not have a bootloader on it. Not after last time, you're going to be kidding. So the code springs into life instantly and says, great, the very first thing I've got to do is switch on PB4. So PB4 down here gets switched on and powers up this MOSFET, which then drags this gate to ground, and therefore we can release the switch. Now all that happens in about, 2 milliseconds, if that. So quick. So great, so the ATTiny85 at that point has switched on the circuit to keep the whole thing going. That's great. Oh, did I just move that? Great, okay, and fine. Now though, the microcontroller that we're connected to, the Arduino in this case, is also powering up along these same power lines. Look, so it's powered up exactly the same, and it's sprung into life. That's great. When we ever switch this again though, push this push button again, this pin PB2, pin 7, goes low. And it goes low because this gate here is low, isn't it, by virtue of this MOSFET. This MOSFET has dragged this gate to ground with an extremely low internal resistance. I don't know what the 2N7000 is, but even if it was like 5 ohms, which wouldn't surprise me, it's probably less, it's going to be basically ground level at this point. So we're bringing this pin here to ground. That's enough to trigger the interrupt and go, ooh, pin 7's just gone down to ground. What have I got to do? And it sets a flag and carries on. But the code then says, you want me to shut down the power. I'm going to send a signal here from PB3, which is physical pin 2, down this wire to the microcontroller. And then, having brought this PB3 pin low, because that's the way I'm doing it, it's always a good idea to bring things low rather than set them high. Think of the way I2C works and SPI. They're always effectively open collector circuits, so they bring things low to ground to set the trigger off. You don't want to be pushing power out because you don't know what's the other end. You know, it could be a short circuit, you don't know. So bring it low, it's always a better idea. So PB3 is brought low, which triggers something in the external microcontroller. Whether that's in a loop or another interrupt makes no difference at all. But then it says, oh, having sent out that signal, I now want to read a low signal back. So I'm changing this PB3 now, and I'm going to have it as an input pin and wait for it to go low again. Okay, so eventually the microcontroller does its housekeeping, sets whatever pin we've connected to here low, which brings PB3 low, and then the ATTiny85 says, oh, I've received confirmation I can shut down, switch off PB4, physical pin 3, this MOSFET is switched off, which then switches off this one, and it all dies in a fraction of a second. The end. The bells and whistles, if you like, I put an LED on here just to show you when power's connected. As I say, it's all dotted because you probably wouldn't put one on there. It takes about 2 milliamps to run. But what it does do, of course, is flash when you press that button again to shut down. So there is an added value, but it's optional, obviously. Yeah, so that's about it. Now, if you don't get the response back here on PB3 and you decide that this device is hung, it's not working, a bit like my Amazon Echo that I seem to be rebooting 3 or 4 times a day, you press and hold this pin, at which point PB2 is now not acting as an interrupt so much as but a standard GPIO pin, and we measure the time that this has been brought low. And after, in my case, 5 seconds, it says, oh, this pin's been low for 5 seconds now. I'm just going to shut the power off, as I would have done had I had a kill command from here. You'll see all this in the code, but as you can see, the actual number of components is very small. If we compare it to the LTC2954, we still need this transistor at the top with this resistor, right? We still need that. We still need a push button. We still need a chip of some sort. So the extra bits we're adding in here is this diode. It's a 1N4148. This resistor here, just to make sure this transistor here, this MOSFET, stays off until we give it a positive signal. This transistor here, of course, is extra. It's a 2N7000, but they're pennies, quite literally pennies. And if you want to put the LED in with the resistor, well, that's fine as well. So the actual cost, I mean, an ATTiny85 is not going to cost you any more than, say, £1, probably just about $1, just over $1. And that's if you buy them sort of singly from eBay or somewhere. You buy them in quantities of 10 plus, it's well below £1. And the added advantage, of course, is that you control the code inside it, so you can make it do anything you want. For example, on this pin 5, P0, I've used that as a TX pin using the software serial transmit only library. I'll show you that in a sec, so I can have some debugging messages out, the ones you read in fact, otherwise you don't know what's happening inside an ATTiny85. But we'll talk about programming the ATTiny85 a little bit later on. So that's it, that's the entire circuit, very easy. I think we've had enough white screen now, so let's move on. Right, I think it's time we looked at the code. Obviously, most of the code is going to be comments and little bits I've added just to show examples, but it's simple. So let's go over to the code screen and see what we can find. Right, we have 2 sketches today then to look at. This is the first one that you would have to put onto your Arduino or microcontroller of your choice, whichever one it is that you are actually controlling. So what this is going to do is get a signal from the shutdown system to say, I want to shut the power down, you better start closing down your stuff. And it's then got to send a signal back saying, okay, I've done it, you can shut down the power. So I'm just going to whiz through this really quickly. Basically, we've put it on an interrupt pin here. I've called it kill. That's on interrupt pin 2. Therefore, we set that pin to input pull up and put an attach interrupt on it. The attach interrupt means this is my interrupt routine. I've called it Shutdown ISR. You can call it anything you like, but make it meaningful, obviously. And this is the way to attach the interrupt. You say digital pin to interrupt and the actual GPIO pin in the middle. All right, this has changed over the last couple of years, and that's now the preferred way of doing it, the recommended way, in fact. So what happens in the Arduino is once it gets the shutdown request, by virtue of the ISR having leapt in, you want to see that first, I suppose. Here's the ISR. Look, it's a nothing function really. All it's doing is setting that flag to true. All right, I've got a bit of debugging code in there as well, but all it's doing is setting that single volatile variable to true. So when it is true up here, it says, right, detach that interrupt now, because we're not looking at interrupts anymore. We're going to use that pin for something else in a minute. We do some housekeeping, but of course there's no housekeeping to do in this example. We just do a few beeps, and then we say, right, we'll have a little delay pretending we're still housekeeping, sending emails, whatever. Then we say, right, set that pin, that output pin low, and set it to output mode. So that's very simple, isn't it? And exactly how you implement that is entirely up to you. If you don't want to use an ISR, for example, if you just want to poll it in a loop, well, okay, on your head be it though. Right, the ATTiny85 sketch then it's not particularly complicated because it is doing a bit more. These are all the definitions. I'm not going to go through any of those. Software serial, that's the wonderful bit of code that Nick Gammon put together, or at least took the original and then stripped out all the receiving part of it. I'm using pin PB0 because that's the only one I've got left. So what we're saying in here is we're setting up the pin for interrupts and all that. And I've done it a slightly different way here. You can use attach interrupt in exactly the same way. Well, I say exactly the same way. It's not quite, actually. It won't allow, the syntax will not allow a digital pin to interrupt here on the ATTiny85. Maybe I'm running on an old core. I'm not sure. Anyway, but it's the interrupt number you have to put on here. And there's only one for that. It's int0. Interrupt 0, so we use 0 in there, and that's the attach interrupt syntax. There's the name of the actual interrupt routine, the ISR, and I want it on falling. But I've actually written it out longhand there and here. It's the two bits together. That's how we always used to do it on the ATTiny85. Yeah, I'll let you just look at some of these comments in here. It could be of interest. So here's the ISR using that method that I'm using. Basically, all it's doing is setting this variable here. That's a volatile variable, and I'm setting it to true to say, yes, we have had a toggle power request. So that's it. Sets it to true and exits. All the rest of it is just a bit of debouncing code, so we don't get, 20 different interrupts all triggered at once because that switch bounces around. So back into the main loop then, what we're saying is, if we've had a request, i.e. the button's been pressed, we're not already in shutdown mode, and the power is currently on, so what that means is we're trying to shut down now. It says, okay, I've got to shut down. A few messages setting the output pin to low so that the corresponding bit of equipment knows that we're trying to shut down, and then it waits here for the return signal to come back again. And here we're making sure that the interrupt is actually off. Now, if we're not shutting down, we want to power up. We say, right, the first thing we need to do is power up the pin to make sure that MOSFET stays on. That's the LED that I'm also setting on. That's the green one that flashes. You could set that low here, incidentally, and just flash it when you are shutting down. So it's off normally and flashes when you're trying to shut down. It might be a better way of doing it, actually. Bit of debugging, blah, 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 and we just set a flag to say, yes, we're running. If we're in a shutdown mode, so this test here is checking to see whether that external bit of equipment, the Arduino in our case, has sent the low back, and if so, it shuts down the power, calls that routine. If that's not true, it then looks at our button to say, have we actually pressed that button? Are we keeping it low? And has it been low for 5 seconds? Here's the kill time. And if it is, so if all this is true, that is to say we've pressed it, we've held it, it's low, we shut down the power just the same. I'll let you read all these comments. It's fairly simple stuff. The power down routine is here. And in fact, the only important thing, quite frankly, is setting that power pin to low. All this was just me playing about, doing a bit of debugging, so I could run it again and again and again. But once you've set that pin here low, the whole thing dies. And this just flashes that LED whilst we're trying to shut down. Cool, that's it. Now, how do we get the code into the ATTiny85? Good question, let's have a look. Now, this is what I use to program the ATTiny85 and keep it running on a breadboard. This is in fact an earlier prototype that I put together with big chunky transistors and whatnot, but it was a bit of a mess, so hence the smaller one at the back there, but it's the same thing functionally. And this little device I went through in some detail in one of my videos. There it is in that video there, and you can buy this, and it comes as a little tiny board like this one here. And you just solder on the headers and the socket and the LED and what have you. It's a nice little kit. You should really read that or watch that video though of mine, because I've made, as you can see here, a couple of amendments or enhancements to this board, and for the life of me I can't remember what they are. But I wanted it just to reset this chip, of course, not the whole thing underneath. So I think I might have cobbled a few bits together here. There's a capacitor, a link, and a resistor, but if you watch that video it tells you exactly what I did and why I did it. I cannot remember anymore, and no, I'm not going to go and watch my own video. I see enough of my own face when I'm editing this video. But the pins are all here on DuPont cables, and they can be plugged into your circuit, but this thing gets plugged into, as I say, the Arduino. So you have your Arduino, this plugs into that as you would a normal shield, but you have to just be a little bit more careful in getting the pins right. So you count 2 down, 1, 2, leave a gap, and then you plug these in, and it all just goes across there absolutely wonderfully. The program you put onto the underlying Arduino is the Arduino as ISP, just the same, but you tell it, of course, you've got an ATTiny85 plugged into it, and it all works. Now, the downside is, okay, that bit works, and while you're developing your board and everything else, you can both program it here and get it to run in circuit. That's fine. My issue at the moment is that if I were to decide to put this circuit here onto strip board or a PCB, how would I then program that chip on a board? I'd like to program it using a cable like this. So this is a 6-way ICSP header. I was told the other day, incidentally, that ICSP was in fact the old PIC terminology, and it's really ISP for Arduino. Is that right? I'm not so sure. Having come from the PIC world though, I just used ICSP, in circuit serial programming. Anyway, so I'd like to use a cable like this from a board like this one. So this is my super duper Arduino chip programmer, the DIP chip programmer, but of course you can also plug in a header pin here, this one, into there, and then plug the other end of this, if you want, into an Arduino and program away. So I'd like to plug this into here and the other end into my as yet undesigned PCB or whatever, and program that just the same, and I cannot find anything anywhere that does that. There are quite a few boards out there that have a different pin arrangement, but then you've got to use DuPont cables to program it, not just use it in your board, but to actually program it. And believe me, it's not easy to keep moving stuff about to program it, put it back in your circuit and expect it all to work. You'll miss the wires, and well, I do anyway at the moment with my eyesight, but I mean, just putting DuPont cables in the board again, it's not something for the faint-hearted. I really do want to find something that uses this sort of cable. If I can't find something, I think I'll make one. Yeah, so there's a little challenge for the new year for me. Right, so I think what we've proven here is a number of things really. One, if we find something out there in the real world and we think, oh, that's useful, I want an on-off button capability from my Arduino, but oh my goodness, look at that price, that can't be right, it's more than the actual Arduino board. Yeah, and we're talking, I know we're talking more or less price of a cup of coffee, but I mean that LTC 2954 just seemed to me to be overpriced for what it was doing. If it had been 50 pence, we wouldn't be looking at this video now. Okay, so one thing is, just because you find something out there doesn't mean you have to buy it. And you think, well, hang on, can't we do something? We're capable people. We can write our own little circuits and program our chips, and lo and behold, I think this proves that you can. But more importantly, given this channel is all about Arduino, and you guys out there, you're part of the Arduinite family, we can make that chip do pretty much anything. So if the behavior of that LTC chip isn't quite what we want, well, we can make this one do what we want, can't we, instead? So if you don't like that 5-second delay, for example, when we switch off, you want it switching off in half a second, do so. Change the code. It's flexible, isn't it? That's the great thing about it. Okay, I'm going to put lots of links down below then where you can get all this stuff and how much you should really be expected to pay for it, because we don't want to start paying too much. I mean, I know I keep saying it, but the price of a cup of coffee is about the price. We should be looking at some of this stuff. We don't want to be paying, you know, £4, £5, £10 or more on bits of equipment that just are not worth that. So yeah, I'm particularly pleased with this circuit, and I may have mentioned that I tend to avoid the ATTiny85, partly because there's not enough pins on it. There's no serial debugging, but I've proved that we do have it, and it's just awkward to program once you've got it in circuit. But I think we can change all that. So look out for some new videos next year, 2020, when hopefully that will be addressed. Okay, great. Now, I know we've gone on about this on-off delayed thing on the Arduino, but this is it now, the end, until I create a PCB, make it something professional. That's going to be weeks and weeks away. So we're not going to talk about this anymore, but if you found this useful, and as I say, I think this is a simple enough circuit for a beginner to do. Let me have your comments down below. Please do give it a thumbs up if you think it's worth watching, to let YouTube know that. It's not for me, it's not for my ego, I've said that before. It's for YouTube. That's how they measure success of a video. Well, that and how much of it you watch. All right, so if you watch the entire video, so much the better. All right, and I'm not suggesting that you leave it just running in the background either. Right, okay, so yeah, comments down below and thumbs up, and Merry Christmas and a Happy New Year, and I'll see you back in January with some new videos. Thanks very much. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.